Thank you. The reason why I have shown you this video of Muni Seva Ashram is because the subject of our topic is sustainability. Until now, whatever we have talked about has been very abstract, where we have always tried to say, and we learned a lot of technologies, and we learned exergy, we learned about water, we learned about biogas, we talked about photovoltaic, and I think they are all very important elements. But they are still technology, they are just a tool. Until these tools do not reach the last mile, we have not succeeded. But yes, it's very important, it's a building block, and I'm glad that you are the faculty, students, and from industries. And this is what we are trying to attempt, that we want to involve you all into this movement, where we don't just want to create awareness, but we seek your participation. And it has been a great honor for me to be here. And I'm going to talk of a topic which has not been talked about much, and which has not been recognized as a technology which can become a game changer. And you saw the video, the last dish, the world's largest concentrator technology, which is being built at Muni Seva Ashram. So this is a technology which I'm going to talk about, which is a technology called solar concentrator. And a solar concentrator is a technology which concentrates solar energy to produce high-grade energy, which can be used for different applications. So before I talk to that, I want to walk you through the journey, how solar concentrator technology evolved into India. And I was very fortunate that I am the one who actually brought this technology to India. And as today morning we heard from Professor Pandit, actually we should listen to the story of a person to get inspired. But I think that's just a first part, but major things what we need to learn is from the challenges and the problems he faced and failures he had, because actually the learning comes from the failures, not from the success. So I will talk to you about how a technology starts. The first thing to get into one area is first need to recognize that there is a problem. And next slide please. So for me, the first challenge came was, the first challenge was that when I returned from Germany, I recognized that 50% of the Indian population cooks on open fire. 3.2 million women and children die every year because for a simple thing like cooking with the wood or biomass. And I was shocked. And I said, this is a problem. How do I solve it? Unfortunately, even now, after 35 years or 40 years of working in this field, I don't think we have made any real impact. Even now, 50% of the world population, not India, even now cooks on open fire. As we heard today from Professor Pandit, it's an exergy, which is actually very good because we are using biomass for cooking and not electricity and gas. But still, it's leading to deforestation. It is reducing the CO2 absorption capability, and also we have to look at it as a holistically, and that's why sustainability is not about just environment, but try to twin all to different angles and collect all the dots to get a larger picture. So when I realized that this technology is there is a technology called box cooker, which I'm sure most of you know, where you have a simple technology where you can just put these cooking vessels into the box. It's a heat trap. The glass has a property, it allows the light to go in but does not allow the heat to come out. It's insulated, so the temperature goes to 140 degrees and it cooks. Excellent technology, most cost-effective technology. But even after being promoted by Indian government for last 40 years, there are hardly 500,000 users in India. I mean 500,000 people who have it, out of that only 10% use it. So I asked myself, how come a technology which is so effective, so cost-effective and it works, not being spreading? And I realized that the technology is functional but not acceptable by people because it does not do what people want. It requires the people to go out in the sun. It cooks very slowly. It cannot fry. It cannot make chapati. So it only serves a part of the function where you say you can put your rice, dal, vegetable, or you can put a bread in it baked. But it cannot fry and make chapati. So people said, why should we have technology where it does not do all what I want? So I realized there was a need for technology where people can cook fast, where people can have a high temperature so that they can fry and they make chapati. And this is where I realized there was a need for a technology called concentrator. Next please. So this is a parabolic dish, just like any dish antenna, which reflects all the sunlight here at the focal point, and because of the high concentration, you have a temperature of 250-300 degrees centigrade. Now because of the high temperature, you can also fry, you can make chapati, you can cook very quickly. And so I thought, now I have a solution. I have the solution what people faced. They wanted quick cooker that could do everything. So I started manufacturing. So from an NGO, I became a company. So the idea was I became a social entrepreneur. I said I don't want to go and collect money from government or from philanthropists, but I would have my own company where I can make my own profit, and with that I can do what I want. But very quickly realized that there is a big market, unserved market in India. As I said, we have about 70% people live in villages, so there is a market need of 300 million solar cookers. So 300 million families could buy a solar cooker or should buy a solar cooker and use that for cooking, but no one was buying it, except for some few rich people who were a bit environmentally aware. And I asked myself, why is it not spreading? And the answer came by interacting with people. So when I started asking people, why don't you use one, it can do everything what you want, a lady very jokingly said, you know, Deepak, you're a typical man, you all men sit in the comforts of your air-conditioned office, and you expect us, the woman, to go into the sun. Why can't we, the woman, not have the same luxury where we can work in the comfort of the kitchen? So I realized that technology has not to be just functional, but to become real acceptable, it has to also meet the expectations of the user, in this case with those ladies. So I said, now how do I do that? I went back to the inventor of Germany, who was my friend, and told him, I would like to use your solar cooker where the sun comes in the kitchen. I don't want my ladies to go out. And he said, I don't have this technology. The technology has limitation. But if you want a technology, go to my colleague, Dr. Wolfgang Schäffler, and he can do that. Next, please. And then he showed me a technology where you have a dish, parabolic dish outside, which reflects the light in the kitchen through the small opening, and there is a second reflector which deflects the light onto the cooking vessel. Now you can cook in the comfort of the kitchen. But then the cooker, which was costing 10,000 rupees, is costing a lakh of rupees. So the woman said, I want your cooker. I want, because it does what I want, it brings the light in the kitchen, I can cook in the comfort of my kitchen, but I don't want to spend 100,000 rupees, 1 lakh rupees. I can, because in Gujarat especially, we are all money minded. If I put my money in my bank, from interest alone, I can buy my LPG. I don't need to buy a solar cooker. Ultimately, bottom line is always economic viability. So I said, now what do I do? As a company, I had to also not just to make a sustainable product, but I had to be sustainable myself. This is the financial sustainability. So I said, how do I become financially sustainable? Then I realized that I need to change my market, because instead of selling the cooker to domestic cooking, where people are comparing me with LPG, why can't I convert it to a community cooker where we cook for hundreds of people? So then I converted this cooker into a community cooker. Here you can see this is a project which we did for a midday meal program school, where we have 2 dishes reflecting light in the kitchen, and what you see is a solar flare. The temperature is 550 degrees centigrade, and we are able to cook for 200 children. So it was economically viable. We were saving biomass. Government started giving subsidy to promote this technology, and this is how the concentrated technology took off India for community cooking. And very quickly I realized that besides community cooking, there is another big market waiting for me next. But first challenge I faced was, but we can cook with solar only energy during the day. What about cooking at night? Because most of the time people go out to work in the morning and come back in the evening, and they want to cook in the evening. So we developed a storage system where you can cook at night. This is another topic which I would like to talk to you, UPL and our UPL University. How can we work on solar storage together, thermal storage? So this is a topic which is going to open up. So anyway, I received an inquiry from an NGO called Brahma Kumar in Mount Abu, and they wanted to cook for 1,200 people. And when I told them that, look, you can buy the 12 dishes and reflect the light onto 12 cooking vessels, and you can cook for 1,200 people, they said, no, that means we require a very large kitchen. We require 12 dishes. That means we require 6 people. Instead of having 12 dishes reflecting into 12 cooking vessels, can you not make a dish where all the light is reflecting at one vessel on a large vessel? That was not possible, but for the first time we were forced to innovate and then develop a technology where you don't bring the sun in the kitchen, but you bring heat in the kitchen. Next, please. So what we did was, this is the same Schäffler dish, but now it is not reflecting light in the kitchen and cooking, but it is reflecting light onto a heat exchanger, which is nothing but a water tank, and the water which is in the header pipe comes down, gets heated, the temperature in focus is 550 degrees centigrade, water starts boiling, becomes steam, and then always pipe the steam into the kitchen. So the dish can be far away into the terrace or far away from the kitchen, and you're piping the steam in the kitchen, and here you can see the kitchen where you don't cook with flame, but you cook with steam. So this was the world's first solar steam cooking system, which unfortunately was not supported by government. I had to go to German government to get it funded, but this is how the world's first solar steam cooking developed. Next, please. And then luckily I never had to look back, so my company went on to become one of the world's biggest company. And here you see the project which we did at the Tirupati temple, where we have 106 dishes onto the terrace, and we are cooking 30,000 meals per day. So now you can imagine the scale of impact you can make. Again, as like Professor Pandit said today, the larger number you cook for, lesser energy you consume. And because of that, you achieve higher exergy. So this is the perfect example how you can become cost effective, you can have a larger impact. Next, please. And this is the world's largest cooking system at Shirdi, where we have larger dishes of 16 square meter, 73 dishes, and cooked 50,000 meals per day. Next, this is the world's highest solar cooking system which was talked about. This shows that a solar system works also in winter. Because a lot of time we confuse solar energy with the heat. And people say, oh, solar is going to work in Gujarat, Rajasthan because it's very hot. But what about winter? What about in colder region? Actually, a solar system works on radiation or irradiation, and it does not have anything to do with ambient temperature. Actually, lower the temperature, better the irradiation, so better the solar system works. So please understand that solar system has nothing to do with ambient temperature, and this is working in minus 40 degrees centigrade, and they're able to cook this for the Indian Army. And I was never able to understand how can 3.2 million women and children die because of the smoke in the kitchen. Because I was born and brought up in Bombay, I had always seen my mother cooking on LPG, and there was no smoke, no soot. Next, please. But when I saw the Indian kitchen, I realized why people die because of the smoke in the kitchen. Here you see the kitchen of the Indian Army before solar. You can see all the, it was kerosene fired bhatti, and you can see all the smoke, the soot, the noxious gases, the SO2 and NO2, NOx and all, and no wonder people die. You will be surprised, smoking in the kitchen, or it's called indoor pollution, is called the world's third largest killer. After disease and car accidents, more people die because of the smoke in the kitchen than all the war in the world which has taken place. You know, so sometimes we don't even realize it as how something like unseen, unnoticed, invisible cooking can kill so many people. Because we don't see that, and that's why it's called the silent killer. Next, please. And then suddenly we realized that why are we started for a cooking solution, but in the end we wanted to actually not just serve the cooking mess, because ultimately we are a heat generating company, we are able to produce heat. So, and as I said, we came to India on invitation of Rajiv Gandhi because we wanted to help our country. But now we are only helping the big institutions like Shirdi, Tirupati, Indian Army, Sabarmati Jail, good colleges, good schools. But we had not made any impact in villages. So we say, how can we help villages where 70% of the population lives? And then we realized that if you want to help villages, you have to help farmers. Because the person who is the poorest in our country is a farmer, and that's why we keep on reading every second day newspaper, so many farmers had to kill themselves. And we could not understand how can a man who grows food go hungry. And we realized a farmer is poor because he produces a perishable product. Whatever he produces, if he doesn't sell it in a day or two, he has to throw it away, and that's why he is at the mercy of the market, and that's why it's the middleman who makes the money. You will be surprised that a farmer gets only 10 to 12% of the price what you pay for buying potatoes or vegetables or any herbs and all. The rest of the money goes into transport, cold storage, and the supply chain of wholesaler, retailer. So he said, how can we help farmer? And the easiest way to help farmer to convert perishable to non-perishable is food processing. We all know from our parents that whatever leftover from food is there at night, they will convert it to breakfast in the morning. So they just process it in such a way, it becomes edible, it can be stored at night, and the next morning we can eat it. The same way when we do achar, pickle, and papad and all, is also nothing but converting perishable into non-perishable by doing dehydration. So dehydration is another technology where you can convert very easily with low temperature food into non-perishable. So this is an example of solar energy can be used for food processing to alleviate poverty, help convert perishable to non-perishable, and create jobs and value addition at village level. Next, please. Then we said, what are the other things which can do? Then bakery. Like at present, it's foolish. A farmer produces wheat in a village. It goes to the city, that it is then cleaned, processed, converted into powder or meal, flour, and made into bread, and bread come to villages, and actually all the nutritious value of the wheat husk and all, they remain in the city, become the waste, and then it does not come to village, which should become back village. So we said, can we not convert? Can we not reverse the process where a farmer can do all these things and do value addition and not just becomes a supplier of raw material, but also becomes a supplier of finished goods, value addition. So bakery is bakery, you can make biscuits, you can make cake, you can make pizza basis. There are so many things which can be baked, can convert perishable to non-perishable. It can get value addition, it can create employment, and it can be done with solar energy, which is clean energy we talk about. Next. Then we realized that the first and the second World War was because of oil. But the third World War is going to be because of water. This was an article which came out in Time magazine in 2001. So we said, can we not do that? Can we not solve the problem of water, drinking water? And then we realized that we don't have to reinvent the wheel. Because nature does that already. The drinking water we get is nothing but desalination, where the sunlight falls into the sea, the water evaporates, becomes cloud, condenses and comes as drinking water. So we said, can we not use solar energy to accelerate the process so that we can produce desalination from brackish water, sea water on the land area and decrease the surface area, requirement area? So this is a multi-effect evaporator system, but without vacuum, because vacuum is a very complex technology which cannot be used in villages because they do not have power, they do not have the technology to use vacuum pumps and all. So we adopted the technology of desalination by using a multi-effect evaporator without vacuum, and here you can see, if you just reflect the sunlight with our Scheffler dish, which has a 5 kilowatt output, you would normally get 25 liters distilled water per day. By using the multi-effect evaporator technique, where you are doing the heat recovery, you are able to get 72 liters distilled water per day. So these are some simple innovations. We use simple principles of chemical technology, chemical engineering, mechanical engineering, physics, thermodynamics, and we are able to create a quantum jump. So I'm very glad that we have people from academic world and people from industry, and I think we need to fuse the knowledge of academic world and the experiences of the industry to scale it up. Next. This is a technology again we use for sludge drying, for wastewater evaporation, because this is a big challenge. All industries have now wastewater treatment plant because government forces them to, but they are only used when they get a phone call, oh today someone is coming for inspection. Because to operate a wastewater treatment plant is very expensive, so they install it because it is required by the government, but most of the time when they were never used, they are bypassed and the water is going into the gutters or into the bore well, and only used when there is a governance coming up, there is a factory inspector coming, then suddenly they are showing, oh, we have a water treatment plant is working. I'm sorry, but this is a reality at the ground level. So again, sludge drying, desalination, wastewater evaporation can be done with this very simple technology which can be made in villages. It's appropriate technology which is totally made in India and which can do wonders. Next. And this is another fantastic technology which we developed upon at Muni Seva Ashram, where I started my life at Muni Seva Ashram, or with Muni Seva Ashram as a supplier. I started supplying them solar cooking system and solar dehydration system and all. And then one day he told me, you know what, Deepak, you are giving me heat when it is hot. But my major cost of running the cancer hospital, which you saw, is energy. I spend 5 crore rupees every year for air conditioning. I have got 1,000 ton air conditioning. Can you give me cooling from solar energy? And normally, we all learn that to do electricity produced air conditioning, to cooling we require air conditioning, which runs on compression chiller. But they already had a chiller called vapor absorption chiller from the company called Thermex, where they were using steam for producing cooling. And I said, great, that means you already know thermal cooling, you are using the heat of the wood and then producing cooling. I just need to replace your boiler with my solar steam generator and we can do the air conditioning. And this is how India's first 100-ton air conditioning plant was installed in Muni Seva Ashram in 2004, and it has been working since then. So now all of a sudden we started with comfort cooling, because for hospital it was for comfort cooling, for keeping the equipments cool and for the patients. But then suddenly I realized it can also be used for cold storages. And again, cold storage is another technology where you can actually conserve or preserve the food in village level. So you suddenly start realizing that you have solutions at various angles. The idea is how to integrate them. Next. Then I was told by a illiterate man who was a trustee in my NGO. He could not read and write, but he gave a great idea. He said, Deepak bhai, I see that you can burn a piece of wood with your solar concentrator. Can you burn body? And I said, in France there are solar ovens where they produce temperature of 2000 degrees centigrade and melt gold and melt metal. So technology is there, but will people accept it? Because as I told them, it's not about technology, it's about acceptance. And in India, a dead body is not a waste where you just throw it and burn it. You have a lot of rituals. And he said, look, Deepak, you are a scientist, you think in a different world, we think in a different world. I did not believe him, he went away. He came back after some time with an order of 6 lakh rupees. He says, Deepak, this is the advance of 6 lakh rupees, please make a solar crematorium. And I said, how did you get the money? Did you steal it? Because he was a poor man, where will you get 6 lakh rupees? He said, no, I collected from people. And suddenly I realized that we all are very articulate, we can read, write, make presentations, we collect a lot of information from YouTube and Wikipedias of the world, but that is just knowledge. But this man who could not read and write, he had wisdom. He had lived his life, he was a survivor. So I asked him that you are the biggest marketing man in the world, you have sold a product which does not exist and even got money in advance. So I asked him, how did you do it? And he said, Deepak bhai, you try to talk and convince with argument. I talk with different language, the language of heart. I went to villages and said, look, there is not enough wood in our villages. Previously it was free, we could just collect it, now we have to buy it. Now we have to go further away to buy it and it's becoming more expensive. At one day we are going to face problems, so the solution is, why don't we do solar crematorium? And of course people said, oh, solar is great idea, but will our religion accept it? Because it is about ritual, it is about religion, it is about belief. And then he thought of something, he went to Puttaparthi to a religious leader called Satya Sai Baba, made a small model and said, Baba, I want to promote solar crematorium, but people may reject it or not have resistance to it, but if you bless it, there will be no resistance. Baba blessed it, and now because it has been blessed by a religious guru, there is no resistance. So he understood the language which people ask. So I think we need to understand, in the end, our goal is to be able to create a solution and bring it to the people. Just means my complaint to our present problem in the world is that there are enough solutions in so many laboratories of the world, in CSIR and NPC, but they are all in the lab level. Why can't we convert the technology lab to land? But that is because someone is bridging, the bridge is missing, who can bring that technology from land to the community, and this industry needs to do that. The work of an academic is to develop technical solutions, but how to convert it into product and into solutions and into business model is something which we as an industry will have to do. So this is the world's first solar crematorium, again installed at Muni Seva Ashram. Next. Then suddenly we heard of this great challenge and big challenge, the problem which we are talking about is carbon capture. The whole world, as we saw today, the major power, 60% of our power comes from coal. And government has set up goal that we want to now reduce our coal consumption. Coal is not available now, we have to import from Australia, we have to import from Indonesia, it's becoming expensive, it has the problem of ash. We want to move away. It's easy to do, but how do we move out of it? So it's not possible. So government now said, can we do carbon capture? Can we remove the carbon which is going into the atmosphere? And then University in Bhopal, RGPV and RKDF came to us and said, look, we have a technology, or it's a technology available in chemical engineering, where we can extract the CO2 by putting into a column and putting MEA solution onto it. This is an amine extraction, what we talk about. But the problem is that there is a penalty. Again, to remove the CO2 from MEA, we have to spend a lot of energy. Because of that, it becomes unviable. But if you are using solar energy or solar heat, it can become good. So this is how the world's first solar carbon capture plant was installed, has been installed at RGPV. We are using solar generated steam to do that. Next please. So this is the Scheffler dish, which is now, this is a small pilot, so we did it with small dishes. But the challenge is in power plant, you require 4 tons of steam per hour, and here you are able to produce only 10 kg of steam per hour. So then we have to have a technology where you can do and scale it up to be installed at industry level. These small dishes are good for cooking and small property, but industry has no space and industry has huge heat requirement. So how do we do that? Next. So this is also, we not only supply them the solar dish, but we also, my brother is a chemical engineer, so we developed the whole carbon capture plant, including the extraction column and the removal. And the carbon which is captured or removed after it is captured into algae, and from algae is converted into fuel. So this is a very beautiful closed loop cycle, and you will hear more and more about CCS. So I'm glad that in India we have a University for Sustainability, and carbon capture should be a subject which you should actually work upon. And there are so many different routes, and I would be glad to connect you and work with you on that. Next. And then luckily, as they say, nothing succeeds like success. Success brings success. So my company becoming the world's biggest company and coming in CNN, BBC and everyone inspired a lot of people to become copycats. People started copying my technology, and they said, but this technology was developed for focus, stationary focus, can we not increase the efficiency? And so there are different technologies of concentrator. So on the left you see a technology which was developed by IIT Mumbai by Professor Shirish Kedare, a technology called Arun dish, where he has a 160 square meter dish, reflecting light into a boiler and producing steam. It is installed at Latur for running into dairy. On the right hand side on the top is a technology called linear Fresnel concentrator. And then there is a technology called parabolic dish, where you have a half-curved pipe which is also producing steam. We have a 50 megawatt power plant in Rajasthan with Godavari Green. So technologies were there, but unfortunately people install them because there is a government support or there is some subsidy available to it, but then after 1 or 2 years they fail. So we started asking ourselves that how come these technologies are not multiplying? And the biggest challenge we realized was that all these technology were directly taken from the Western world where we developed and not adapted to Indian conditions, and they failed. And because of that, solar concentrate technology got a very bad name, because when I again went back to government and said, now I'm bringing a new technology of concentrator, they said, oh, don't come with concentrator because it just failed, no one wants it. But it's not true. The failure was not technology. The failure was adoption. So I will show you what is the solution. Next. So this is a parabolic trough technology. There are already, since 1972, 380 megawatt power plant has been working in USA in Mayavo Desert near Bakersfield, San Francisco. So technology was there. Now idea is how to reduce the cost, how to make it viable, how to make it in India, how to involve our engineering people, how to involve our civil construction people, which never happened. Because industry wanted a proven technology, they went and purchased it from a company in Israel or company in Mexico, and they came to India and we started paying in dollars. It became expensive. We did not hire local people. There were more and more consultants, and local people were employed only for digging the ground. All the other things was done by machine. And we realized that if you want to change and become sustainable, we have to do everything at India at a level that is make in India. Next. So this is another technology called heliostat, where you reflect all the light at one or tower technology at one point. So there are enough technology available, but the idea is all this technology we have been brought to India, done in megawatt scale, but never multiplied. And this is where we started asking ourselves. And luckily, I had sold my company, Ghadia Solar, and moved to Muni Seva Ashram. I'm a trustee there. And then suddenly one day I got a phone call from a company from Australia saying we have been invited by Vadodara, which is the Narendra Modi's pet project for a smart city, and they want to do desalination, and they had identified this technology which they had as a game changer and wanted them to come to India. And they wanted to look for a person who is an expert in India in that, and then so they approached me. And then I looked at it and said, wow, it's a great technology, why can't we bring it to India? Next. So basically, from my side there was a lot of resistance. I said, no, I don't need any technology, because I was already doing for 35 years successfully, having done so many projects. But then I also, as I said, understood the challenges. First challenge was availability of space. Is there enough space available at industry who wants to use it? No. So just like in cities, instead of having a society with 200 houses, you have got 200 flat. So instead of being horizontal, you go vertical. So the Australian, what they did was they developed a technology, a dish of 500 square meter, which requires only very small footprint. So just to give an example, at Muni Seva Ashram, we had installed 100 Schaeffler dishes of 12.5 square meter to do 100 ton air conditioning. And I required 2,500 meter of ground area. Now this big dish requires only 625 square meter. So 1/3 the footprint, and the efficiency is double. Instead of requiring 1,250 square meter reflected area, it requires only 500 square meter area. So it was doubling efficiency. So I realized that there are technologies where I need to apply Schaeffler for fixed focus concentrator, stationary focus. But if I want to do only heat generation, I don't need to use the technology. I need to go for a technology which is more efficient, where you have a dual axis tracking, where the dish faces the sun and you have a high concentration ratio. So we are bringing this technology to India. So this is on the right, you see a dish which was developed at ANU along with the company Sunrise CSP. Next. And the idea is that again, just in Tirupati we had 106 small Schaeffler dishes. Now you can have multiple big dishes of 500 square meter, and it can become megawatt and gigawatt scale. Next. And the advantage, what is the new technology which we are bringing now, and which is the solution for all the industrial applications, because photovoltaic is a fantastic technology. Fix it and forget it. There is no moving part. The sun will fall. It works in diffuse light. So we are no way competitor to photovoltaic. If you want to produce electricity, go for photovoltaic. But industry does not require just electricity. The industry, 60 to 70% of the energy required is in form of heat. And this is where photovoltaic cannot work. And it's a crime to produce electricity for heating. Because again, as Professor Pandit said, we produce electricity very inefficiently with just 25, 30, 40% efficiency. And then again, if you are converting it to heat, then it's a crime. So why not directly use solar energy with the efficiency of 50, 60% and directly use it? And again, it's a clean technology. So if you want any heat, solar directly thermal energy generation is good. But previously thermal was used only for hot water, for bathing, for boiler water preheating, because we could not go to higher temperature. But now we have a technology where you can go to high temperature, and you will be surprised the temperature which we reach in the focus because of the high concentration is 1700 degrees centigrade. So now you have got a high grade energy which can now first be used for producing electricity, running a turbine, and the steam coming out after the turbine can be used for heating or it can be used for cooling. So tri-generation is something we are talking about. Initially people talked of only power generation, and power generation previously could not have cogeneration because power generations were always somewhere near the coal mine, where they only produce the electricity and put into the grid, which sent them hundreds and thousands of kilometers away. Now industries, they have now started putting the captive power plant. Now they require heat also, so they started going for cogeneration. So all sugar factory, as we heard today, are now going for cogeneration. But again, it is a technology where they require raw material, and raw material is expensive. It is a problem of logistics, so why not use natural energy which is available to us for that? So now you can produce electricity in form of cogeneration, trigeneration. It can be used for grid stabilization, because PV and wind energy are great at technology and very cost effective, but you cannot predict them. Suddenly it may be there, suddenly it may not be there. And storage of photovoltaic energy in electrical batteries are very, very expensive. So thermal storage is 1/3 the cost, molten salt storage is 1/3 the cost of electrical battery. So it can be used now for grid stabilization, so because when you, at present only 5% of the power comes from renewable. So our grid does not have problem. But as more and more people start installing solar photovoltaic power plant and windmill, our grid will become very unstable, because suddenly you have more power, suddenly you have less. In Germany, there are times when 100% power comes from renewable energy, and they have to shut, government will give power free of charge so that it is used, otherwise, and people start using energy for applications they don't need just to use it. Then, as I said, it can be used for agri-processing. You can produce milk, pasteurization, UHT milk, hydrogenation, gasification. It can be used for making fertilizer. It can be used for waste processing, converting waste to fuel, fertilizer, sludge drying, incineration, water purification. We talked about urban village solutions, district cooling, district air conditioning, sterilization, cooking, cremation, fuel production. The whole world, India has a very big program. At present, it's very sexy to talk of green hydrogen. Great, green hydrogen sounds good, and that is the solution of the future. But for green hydrogen, you require energy, electricity, which comes out with only 20% of the efficiency from photovoltaic. And electrolysis is a process which still has not become viable, but with higher efficiency you can do with this thing. So there is a company in Switzerland which is producing hydrogen and supplying for aviation fuel to produce kerosene out of it and producing hydrogen for it. And metallurgy, steel making, they also supply gas, syngas for producing cement and steel, which is green steel. So the future is going to be chemistry, solar chemistry. Solar energy is not just to be used for producing heat, but it should be used for high-grade applications, and gradually the product coming out of it can be used for multiple applications. Next, please. So the first system is being installed at Muni Seva Ashram now. That's why I showed you the video that the dish is already up and ready. And it is in first phase we are using it for extraction of essential oil, space cooling, that is air conditioning, and steam cooking. We cook for 2,200 people. Next. In next phase we are going to increase the number of dishes and produce electricity, and then we will also take the steam coming out of the extraction turbine for process heating, cooling, and other applications. So it's trigeneration. Next. So this is the dish in a schematic. Next. The advantage of this technology, when we brought to Australia, from Australia to India, we said nothing should come from Australia. There should be only know-how transfer, and that also everything happened via internet. Not a single Australian could come to India because of COVID, which is a blessing in disguise for us. That forced us to develop the technology in such a way that we made the machine to manufacture the structures locally. We make the mirrors now locally. In Ashram, we develop technology ourselves with their support, of course. So here you see this is a factory in the field. So the technology is such that it's not just made in India, it is made at the site. So if you come and place an order for 1 megawatt of our dish to us, what we do is we come with our factory to your site and manufacture everything. We just bring the roll, steel roll, and just bring the pipes, and then everything is done locally. So it is factory in the field. So you see the structure, the framework is done locally there at a site. Then there is a jig on which it is placed. Next, this is all the photograph of Muni Seva Ashram. Next, please. So this is the jig on which the whole system is ready. Next. Then, of course, to make sure that we require a very high concentration. We require 2,000 sun. That means the dish has to be accurate to 0.002 millimeter. So to make sure that it is that accuracy, we have a photometric system where we take photographs from 26 meter height and then project points, and then again with photometry find out if the accuracy is achieved or not. And this is the technology where very high precision parts are made by people who cannot read and write. So this is the beautiful fusion of how do we bring high technology to the lowest caliber of people. Next. This is the structure that is being added to the dish. Next. We'll just quickly go through. Then with crane, of course, we have to now put the heavy parts. The weight of the dish is 26 tons. Next. Next. Now the dish is ready to be turned over. Next. So now it is being lifted and put on its backbone. Next. So now it is sitting on its back. Next. Now this is the foundation on which the dish has to be placed. As I said, the weight of the dish is 26 tons, and it's not the weight of the dish, but now because of the dish is 25-meter dia, there is a wind load, and wind load multiplied by factor 4. So we have to make sure that even in 180 kilometers, the dish should not fly away. Even if a banner is there, we make holes to make sure that air goes away and does not tear the thing. So we don't want the whole dish to be lifted. So it is so beautifully designed that it can be still 180 kilometers with automatic security system, where when the wind starts increasing, the dish will automatically move into the position so that it has minimum wind resistance. Next. Then it is rotating along with the sun in both direction, in east-west direction and north-south direction. So the whole system is tracking. This is the east-west tracking, where the whole structure moves in east-west direction. Next. So next. Next. Just to show you the tracking. Next, just a 2 kilowatt motor is driving a dish of 26 tons. So beautiful engineering. Everything is done, calculated. Next, now the dish is going to be positioned on these pivots. Next, so now the dish is being lifted. Next, the dish is now already onto the structure. Next, this is the automatic tracking system with software, where you can position it anywhere. It has to be operated totally as independently. You don't require any operator. So the system is so designed that it senses automatically that at this latitude the sunrise is going to be. So in India we were very fortunate. We had Panchang, where we could predict the sunrise and sunset for earlier since 5,000 years. Now it has become logarithms and all that. So now we are combining technologies, old technology, new technology, and putting into functions to make it a high-tech technology. Next. This is the control cabin. Next. And then we have a automatic alignment system. So this is a pyranometer, where we are able to measure solar radiation for every minute, and then able to find out what will be the steam output at what radiation. Because in the end, industry does not want to go into detail. Just tell me how much steam I will get, how much is usable, and will my process work. I don't want cheap energy, I want sure energy, and my process should not fail. I don't care about the cost, but I cannot let my process fail, because this is chemical industry, process industry. Small variation in temperature or pressure of steam can spoil the whole batch. Next. So this is again the bird view of the system at Muni Seva Ashram. Now the advantage is that already there are so many power plants which are now being closed. So now basically we can go and tell, look, there is already a power plant installed, 500 megawatt. Now installed solar concentrator, produce the steam during the day, the turbine is there, the network is there, the evacuation is there, and we can do that. So it can be already used into existing area. It can be integrated seamlessly. It can be hybridized. So during the day you can work with solar, at night with existing coal or gas, or with storage you can also use with solar energy. Then it can be used for grid stabilization, which is a big challenge, and it is made in India. Next. So basically what changed the whole perception was when Dr. Abdul Kalam heard about us. And Dr. Abdul Kalam, we know him as a man of technology, but you will be surprised that Abdul Kalam was actually a people's president. After becoming the president of India, he realized that technology is just a tool, which I talked about earlier. He realized that technology has to reach the last mile. And he realized that if I want to make my India a developed nation, it can only happen if I am able to raise the 70% population out of the poverty. But unfortunately, if you look at our villages have become nothing but they are supplier of manpower and food. So actually you go into a village, most of the youngsters in the village get up in the morning, sit on the bike and go into the town nearby to work. No one wants to become a farmer, so even the food supply is going to be sick, and they create problem of infrastructure, accommodation, crime, water, sewage and all. So the idea is how can we create villages which can become smart villages. Instead of smart cities, we require smart villages. And this is where Dr. Abdul Kalam heard about us, and someone said, Dr. Abdul Kalam, why don't you go to Muni Seva Ashram? It's a 1,000-acre campus having a schools, hospitals, old age home, vocational training center. Totally green, totally clean, self-sufficient, organic food, 600 cow. So he was surprised. So he came to us and he said, wow, Deepak, what you've done is great. I'm very proud of you, because Dr. Abdul Kalam's vision was something called PURA. It is providing urban amenities in rural area. So he said, you have really fulfilled my dream, but my problem is that what you have done, you are able to do because the ashram gets enough donation. But I have got 650,000 villages. I want each and every village to become self-sufficient. Can you develop a business model so that this technology can reach the last mile? And the answer was again not to be found again. It is not to be reinvented, because all the roads which are built now, when I came from Vadodara to here, I have to pay toll 2 times. They are built by the private party. They collect the taxes when I drive through them, and after 10-15 years, once they have recovered the investment, they are going to transfer it to the government. That's a model called boot model. So in the same way, we are installing this 1 megawatt power plant on board model, where Ashram does not invest anything, does not take any technical risk, does not take any financial risk. We as a company supply them electricity, we provide them heating, we provide them cooling, and they will recover the investment by what they pay, and they pay 10% less than what they are spending now. So they are actually already benefiting right from the day one. And then the system becomes free to them, they can take over, or it can be run. So next please. So these are the different directions. So we have 10 more minutes, means I was told that it's 1 hour, so I don't want to draw the time. You have been really brave. I have never seen people sitting right from the morning since 10 o'clock, and you must have come at 9 for the registration, and it's 6 o'clock, and I have been trying to see how many people are sleeping. The Prasad had that challenge, and at the last, you are the challenge that you are exhausted. You have heard so many things. You want to try to remember everything at the same time. You are hungry. You want to go back. Some people have the bus to catch. So I will stop here. What I would like to do is I would like to invite you to Muni Seva Ashram to see the place where all this technology, from solar crematorium, solar air conditioning, solar dehydration, biogas bottling plant, so technology over there. What we require is participation, active participation of people like you who come and work with us. We have enough challenges which we face, and we want to work with you, your students, your faculties, to develop solutions. If that can be an investor, why can't we do it? So I'm glad that we had this connection which was missing between industry and academic world was there. We have stopped counting on government. Government should just not come in our way. If they want to support, they should. If they don't, let us not count on them, because subsidies bring corruption, bureaucracy, paperwork. So we are happy to do without them, and let us become a sustainable model, not only for providing solutions to industry, but to villages, to the mankind. And India can become again a technology hub, the way IT could take out India, from a poor country into a global IT. I think alternative appropriate technology, solar, biogas, and water. I think we have so many solutions, and India, luckily, we have been forced. Necessity is the mother of invention. So we have been forced to reduce cost because we are a poor country. So we have a great engineering pool. We have great academic world. And if our Indians can go in USA and succeed, why can't we do it in India? So again, it's a challenge which is on to us, and I'm sure together we can solve them. So if there are any questions, I'll be glad to answer. Otherwise, thank you for staying the whole day. I was worried that by the time the chief guest goes away, 30% people who come with him go away. By afternoon, another few people go away, and last people just go away. But I see that you are still full, maybe 2 or 3 people have gone. So thank you again, like Prasad said, it shows that you are really interested, you are hungry, and it's our job to make sure that you go back today happy, thinking that yes, there is a hope for us, there is a work for us to do together. Thank you. Jai Shri Krishna.